All right, thanks, John. Good morning or good afternoon, everybody, and thanks for the opportunity to talk in this forum. Apologies, I could not be in Adelaide due to travel restrictions, as many of the speakers have mentioned before. So today I'm going to talk about activities in BlueScope aimed at reducing the CO2 emissions by the company. First, a brief introduction about the company. We are a global manufacturing company, mainly towards building solutions. Our products are aimed in there. And we have footprint in 18 countries around the world. The integrated steelworks in Australia, we've got electric arc furnaces in the States, and various operations in many Asian and Southeast Asian countries in there. So we are based in many developed economies and developing economies as well, and I think there is a good chance of high growth in many of the regions that we are located in. We mainly focus on flat products. So basically, these are the type of things we do, flat products in here. So in Australia, we only produce flat products in here. Same in New Zealand, but New Zealand, they produce long products as well. In the States as well, we focus on long products. In Asia, it's mainly coating and painting lines in there. So today's talk, I'm going to focus on one topic, and this is the carbon and climate change. And this is a page from a release to investors that the company has put out earlier on this year in there. So what does the company have in carbon and climate change? I put this summarizing slide, and it is divided into three, if you wish, sections: Horizon 1, Horizon 2, and Horizon 3. In the first one, the company wants to achieve the 1% reduction in CO2 year on year, and that's from 2018 to 2030, a period of about 12 or 13 years, basically, in there. And again, to empower local sites to take a local action under Horizon 1. So these two are mainly focused on implementing projects to improve energy efficiencies and material efficiencies in there. Most of the presentation will be focusing on these two points in here. In the medium term, we are preparing for a major investment decision, and that's mainly to realign a blast furnace in Port Kembla. The operating blast furnace BF5 has been or was realigned in 2009 and has been in operations since. We estimate that the next reline has to happen between 2026 and 2030, say. So for then, we will talk a little bit about what is available for us in the reline option in terms of options to reduce the CO2. And then Horizon 3, it's the longer term one. We talk about the 2050 or thereabouts in there. So I'm going to take Horizon 1 first, and this is achieving the 1% year-on-year reduction in CO2 emissions, and the activities are mainly divided into two parts. The first part is implementing the low capital projects, and I must emphasize that these are local projects in there, and mainly they are suggested by engineers, plant engineers, research engineers, technical engineers, and that's what we call AAA projects in there. And there's a fair bit of that as well, focused on material efficiencies. Okay, and this is some ideas taken from the World Steel Step Up project as well. Together with these projects in there, there's capital projects in there, and implementing projects as they lie on the abatement curve, on the marginal abatement curve, on the MAC curve in there. We're taking the left-hand side ones, the ones that have good return but low capital requirements in there. And then we will talk in a little bit more details about the biochar. That's a good possibility if we can improve it, if we have a good supply of biochar in there, and possible activity which may or may not have a good return on CO2 reduction. This is the capturing of the LDG gas in there. So in terms of the capital projects in there, I'll talk maybe before, in terms of these projects, I'm not going to talk very much about them, but they really sort of include like improvement of sinter plant operations, reducing leakage in there. They could include the projects in the coke ovens, improving battery heating. They could include slab hot linking, improving gas balance around the plant, and so on. So I'm going to focus basically on this one in here, on the biochar in there. So we have a history in studying biochar and its applicability to steel making applications basically in there. The one major effort was between 2006 to 2013, where a joint project between CSIRO, One Steel /Arium at the time, Liberty One Steel now, and ourselves in there. And that really covered a wide range of topics in there, as you can see. But the focus, I'm not going to go through all the activities, but the focus is on the biomass, and closely linked with the biomass, the source, the supply of the biomass, and therefore our interest in charcoal production and supply chain in there. So in those 7 years, we covered a lot of grounds in there in identifying possible applications. We did some fundamental studies, we did some experimental studies in there. And until basically we came here, we put an application for some funding, and we were ready to go in some plant trials, substantial plant trials. And the biggest one would have been the blast furnace, trying to replace some of the pulverized coal with charcoal, up to 30%. As a matter of fact, we were going to do it in stages. And there, 1, 5, 10, 15, 20, maybe up to 30% replacement of the PCI in there. It has a very high potential of success in there. And other places in the world, they use charcoal, maybe in small furnaces. In Brazil, there are blast furnaces operating on charcoal exclusively, basically, in there. The second major application we identified is to use the charcoal as a recarburizer in the BOS in there operation. And again, during the preparation work, we have some experience in that. We did prepare some locally prepared some charcoal, and we did try it on the AF furnace in there, and that was successful in all regard, basically, in there. And a third, maybe less important application would have been to replace a fraction of the fuel used in the sinter plant with charcoal. So that was the past, and up to 2013, 2014. Since the company committed itself to 1% year-on-year reduction, we revisited that option in there, and we concluded that the use of charcoal or biochar made from waste is still a viable option right now to really reduce the CO2 emissions in there. And the results that we have mentioned, they're still current in there. And we would like to really source some biochar. We are actively looking in that space in order to really do a proper plant trial. And that, as I have mentioned before, mainly on two fronts, the BOS recarburizer, and to substitute the pulverized char, the pulverized carbon injection in the blast furnace as well. So we are active in there. So the hurdle is really to find a suitable supplier of charcoal quality. So it's the quantity and the quality of the charcoal that is the challenge facing us at the moment. In there, worldwide, there is a limited, basically, market for charcoal in there for obvious reasons. That has to be renewable. So it's something, the model of ArcelorMittal in Brazil, where they have plantations, and the lifetime is 7 years. So they've got a 7-year cycle of planting, growing, and then harvesting in there. That will be a good model, but it's not widely common, that model in there. And sourcing a large quantity of charcoal of specific quality is quite a challenge. And that's where we are at the moment, looking actively into different options where we can secure the quantity and the quality that we need for the two applications that I've mentioned. Okay, if we move on to the Horizon 2 section in there, and I would probably limit the discussion to the relining of the blast furnace in there. And unfortunately, in there, the options are very limited. That we don't have many options in there to really reduce the CO2 emissions significantly. There are a number of options, mainly to deal with improving energy efficiencies, such as installing top recovery turbine on the furnace. And there we have one on the existing number 5, and there, which will reduce that will improve the energy recovery a little bit in there. We have a reline team already, and they contacted major suppliers around the world, and the reply was unanimous that basically there are no technologies that will provide significant CO2 in this coming reline for us in there. So what can we consider in this space? Perhaps a DRI option, but that is not foregone conclusion for us, because it relies heavily on natural gas price, and the price we pay for natural gas in Port Kembla, it's quite high. It doesn't really work for the DRI option, perhaps unless that price goes down significantly in there. We probably pay 3 times, if not more, than what the price should be to really for this option to be economical. Okay, so to put a little bit of context into this whole discussion, I think it was mentioned a few times this morning in John's presentation. The EAF option is around, if the steel produced by the EAF route, it's about 0.6 tons of CO2 equivalent per ton of steel. The DRI EAF ranges from about 1.5, 1.6 downwards in there. And the integrated route, and it's got an average, international average, about 2.3 tons of CO2 per ton of hot metal up there. But some countries like Japan, I know they operate at 1.8 or 1.9. This is not our average. This is a worldwide average in there. So accounting is very important these days. Numbers are everything in there, and where you put your boundaries has got a big impact in there. For Scope 1, for the Australian operation, it's about 6.3 million tons per year, our emission, our footprint in there. And Scope 2, it's about almost 9.5 million tons per year. Let's focus a little bit about Port Kembla, where the integrated steelworks is located in there. For the 6.27 million tons per year, as you can see, the majority of that is in Port Kembla. 80% comes from coal, 9% from electricity, 9% from limestone, and 2% from natural gas. Now, obviously, if you really want to reduce the CO2 emissions, it's logical to look at the biggest factor in there, and how can we reduce our dependence on coal. Well, there are thermodynamic limitations of the process in there. The iron oxides need to be reduced in there. We need a reductant in there. In this case, it's carbon in there. In this figure in here, what happens to the blast furnace gas and the coke oven gas, all the indigenous gases in there that we produce and currently we reburn, is a big factor in there. What I mean, is there an option of converting these gases in there into some useful products that do not end up being burned? Some chemicals or there are some technologies to convert them to ethanol, but unfortunately ethanol is burnt mostly in petrol again, but there are other options in there that may make a difference. But in general, this figure in here is really dependent on what happens to the indigenous gases that we produce. At the moment, we use the blast furnace gas and the coke oven gas as fuels, and the LDG, the BOS waste gas, at the moment we actually flare it in there. So there's an ongoing discussion on this topic in there. Electricity is the other very interesting topic in this section in here, because it could have a big impact if it becomes available from renewable sources, basically in there, because there is an option in here of trying to really generate electricity from some of these gases. But again, we have to be careful in the balance, in the accounting thing in there. So that's the second scenario, second horizon. On the third horizon, that the company recognizes that in 2050, it needs to be centered around new breakthrough technologies. But at the same time, we recognize that 2050 is a fair few years away in there. So what can we do now? We probably would be watching very, very closely what happens in the hydrogen space when and if it becomes available from renewable sources and at a reasonable price, as we have heard regarding the price per kilogram a number of times this morning. And we are probably happy to participate in selective R&D programs that we think that have got high potential in this space as well. So to summarize, BlueScope is committed to the 1% reduction in CO2 year on year between 2018 and 2030. And the main activities have been so far in Horizon 1, which these activities are focusing on energy efficiencies projects in there, and other projects that are focusing on materials efficiencies using high-grade ore, using pellets. There are many in that space in there. Horizon 2, the reline, that's likely to happen in, 6, 7, 8 years' time, does not really provide us with big, significant options to reduce the CO2. And for the breakthrough technologies, we are watching with great interest. Thank you.